Okay, so now you're really only looking at current supplies. This is my second video today, again for 285, and now I want to concentrate on only current supplies. So current supplies supply a current. So if I say this is 10 milliamps, and there is a resistor here, and from here, actually there's nothing else, 10 milliamps, and I ask you what is the voltage here, VR, and this is a 1 kilo ohm resistor. Here's the way to answer it. So this, we know for sure that these 10 milliamps are going this way, and out this way. So in red here, I don't know if you can see it well, in red, the is the direction of the current that I want. So the voltage across that resistor is really, V1 is this way. So I can write by Ohm's law that V1 is 1 kilo ohm times 10 milliamps. So V1 is 10 volts. But I am asking VR, and I know the VR is minus V1 because VR is swapped from V1. So VR is minus 10 volts. The point here is to just show you the 10 milliamps, but I figured maybe this one example will help people. And now let's talk about how to deal with Ohm's laws. I mean, sorry, not Ohm's laws. How to deal with several current supplies in parallel. So first of all, let's appreciate that these branches are all in parallel. So this side here, this is my green node. The other side is going to be my orange node. Oh, it looks like I had two highlighters here. That's good. So this is my orange side. And branches in parallel, the definition is any two branches, or more, that share two nodes, they're all in parallel. So between orange and green, everybody who's between orange and green is in parallel with each other. So here the minus 2 milliamps, 1K, 3 milliamps, and 4 milliamps, and 2K are in parallel. This means we can swap them all we want. It's a free-for-all. So the 2K is in parallel with the 1K. So I'm going to say that the equivalent circuit, which I'm going to draw here, will have a 2K in parallel with a 1K, and 2 times 1, 2K times 1K, divided by 2K plus 1K is 2/3 of a K, and which is what? 3 times 7 is 21, so 0.7K. So I'm going to call this 0.7K, and this will also be here. So I'm going to give you two equivalent circuits to this one. And now let's do, so we got rid of the 1K and the 2K, but now we have the three current supplies in parallel. So again, we swapped the 1K put here with the 2K, and they are both here. Now I'm looking at the 2 milli, 3 milli, and 4 milli. And I picked, usually you should decide on any direction you want. Going down or going up doesn't matter. But decide and draw it. Once you draw it, there's a point of reference. So I want everybody who's going down is going the same direction that I chose. So this one here, I'm gonna write in red my X, and this is gonna be Y. So for X, what happens is the 3 milliamps are going down, so they are in the same direction as my X, so I'm gonna give 3 milliamps to X. The 4 milliamps are going the other direction, so instead of adding to the 3, they're gonna subtract from 3. The 2 milliamps, it's minus 2. Minus 2 are going the opposite direction. So they're going to subtract from 3, but it's minus 2. So it'll be 3 minus 4 is minus 1, plus 2 is 1, I think. So I think this is a 1 milliamp going down. Once you know this, you also know that Y is minus 1 milliamp going up. But let me do this again, just to make sure my math is correct, because I mess up math all the time. So let's assume I want Y going up. I look in the original circuit, and whoever is with me, there 4 milli is going up, and -2 is going up. I add the 2. So whatever the number here is written, I copy 4 and -2. Oh, -2 milli. Oh, don't make this mistake on the exam. Leave the milli there. And the 3 is the opposite direction, so I'm going to say minus, and then I copy the 3 milli. So 4 minus 2 is 2, minus 3, oopsies, minus 1. Okay, it's not working for me here. Y is -1 milliamp, like we had said. I hope this helps with current supplies, but if it doesn't, send me an email.